Hello everyone, this is Mr. Ege and I'm just going to demonstrate today how to use the quantum science in making a billiard table. Billiard table we're going to generate is going to be within the inventor, okay? And we are focusing on the statistical differentiation of the possibilities and values of the scoring in a billiard game. And inventor, when you start the inventor, okay, one of the first things you want to do, setting the units. Units are going to be in millimeters. So I suggest you to do that by just simply going to the tools and then go to document settings. Make sure that the units are set to millimeters and the mass is in kilograms. Okay, then once you do that, you're ready to create your own design. And I suggest you to select XY plane, and within the XY plane, create a square. And make sure that square is dimensioned to 2000 millimeters by 2000 millimeters. And that's 2 meter by 2 meter, okay? A model, solid model for billiard table. And when you finish the sketch, you're going to extrude this, okay, 100 millimeters, 150 millimeters, okay? And that is the basic, the bulk part of the solid model part of the billiard table. Click. And this is not necessarily finished at this point. We're just starting. Then move on and create a new extrusion, okay, on the surface. So select the surface of the solid model and generate a second square within on the surface of top surface of the solid model. The new square will measure 1800 millimeters by 1800 millimeters. Okay, it's a slightly smaller version, okay? And once you create this square and center it perfectly as much as possible, finish the sketch and please extrude 75. Extrusion will be 75 millimeters. Negative extrusion so that we can make a depression on the surface of the old solid model. Okay, we're going to subtract, and we're going to use the subtraction or negative Boolean cut type of Boolean feature. Okay, extrusion will be downwards, and it's going to cut type. And when you okay that, you will supposed to get a depression like the way it's shown on the screen right now. Okay, but however, we need to make 6 holes. Okay, and how do we get to the 6 holes? You select the surface first, okay, and switch it to the top view, and each one of those holes will measure I don't have the dimensions for that yet, so I suggest you draw a square to locate the center of the holes first of all, and there's a second square is 1670 by 1670 millimeters, a second square, and also dimension for each square will be 130 millimeters. Okay, so we need to draw circles. And I'm going to just zoom in here and pull this out. Okay, that's the dimensions, 1670 millimeters, the size of, and this particular 130 millimeter is the diameter of the circle. Okay, this is important. Okay, 130 millimeters diameter of the circle for each one of the 6. Once you draw one circle, you copy it. Okay, from corner to corner to corner to corner. And at the end, we're going to extrude all of them. Okay, so if you finish the sketch, all right, and make the cut type of extrusion, the type of the extrusion will be 75 millimeters and cut type. Okay. Once that is done, okay, and you're going to have 6 holes. Okay. Now, I'm going to just take it back to this assembly drawing that I created earlier. Now you need balls. Okay, then this billiard balls are going to be, I'm just double clicking to show you the part drawing that I generated for you. And the part drawing, solid model part drawing is going to come from the revolution. If you choose XY plane and look at the design that I generated for you, it's a half circle, okay, with the diameter of, or 2 times the radius, diameter of 100 millimeters. That needs to be created with the half circle. You create one circle and then you trim it off, okay, after you draw the diameter. And you need to have circle so that you can use revolve command to generate a sphere, okay, and the dimension for that is 100 millimeters. Realize that diameter of the hole is 130 millimeters, and 100 millimeter size ball will fall in through the 130 millimeter hole. Okay, so once you generate this, okay, you simply go and use the revolve command. So I'm going to finish the sketch to show you the revolve command. Revolution is going to be, the revolution is going to 360-degree revolution to create a sphere, a perfect sphere. That ball will be placed or inserted into the assembly drawing. So once you're done, you create an assembly drawing, insert the table, and also you need to insert, okay, the balls. Okay. So, and what is it next to do? Dynamic simulation. Dynamic simulation is critical at this point, that you literally go to environment, select the dynamic simulation, okay, and then first things are first, you insert the joint, okay, and you establish 2 kinds of joints, okay. First of all, there is a relationship between each one of the quantum balls and the quantum billiard table. So you need to establish that, okay. And then second, each quantum ball also will have relationship with each other, okay. So the first relationship with the balls and the billiard table is called spatial relationship. And finally, you need to establish the contact type of relationship between the quantum balls. Okay, once you accomplish that, you need to position the balls, of course, okay, and make sure that the table is also grounded and balls are not grounded. All right, and then we're ready to quantum play. So simulation setting, okay. I'm going to position those balls to show you the position of them so that each ball fall down, and as they fall down, they're gonna impact each one of them, okay. The center ball is right at almost a little bit center, right about 100 millimeters or so above the table, top of the table. The second one is also about twice as much high, and the third ball is 4 times as much high, okay. And I have to design that. I'm just going to go to simply simulation setting and the play. When you click on the simulation player, you're supposed to get a control, and I'm going to demonstrate to you. I'm using two screens, and I want to demonstrate. This is the control, okay? And when you click on the play button, it will show you that falling objects rolling around, and then falling the holes. And look at this. I tried this quite a few times, so all three of them will fall, but initially none of them did. So apparently it works. And when this is done, one of the things I suggest, bring it back and create a movie file out of this, okay? Actually, chances are almost near to zero to score from this configuration, but because I aligned it earlier, the way that it scores, all three balls will fall through the three holes, okay? That all of a sudden I increase my chances to 100%. Okay, so if you click on the publish movie, you can literally quantum balls and save quantum. Quantum billiard. And save this AVI file. And I'm going to use the codec, Intel IYUV codec system. And I'm going to play it. And there are impact forces. There is jumping. There is rolling around. And then as first ball falls, now the second ball falls through, and the third ball continues to fall. All right, thank you very much for your time. Let's accomplish this one all together, you and I. And if you have any problems, call me. Thank you.